Okay, so in this video, we're going to take a look at a few more questions, okay? Following on from the last video, where we start to make the connections between the written out function and what the graph looked like. We're going to do lots more now in this video just to really practice that concept because this can be quite tricky. So the important note from that last video, this is the kind of the note that you kind of really need to learn off by heart, I suppose. It's the setup of the graphs, all right? So you're either going to get something that is in the form y equals a plus b sine cx or y equals a plus b cos cx, all right? You're only going to have transformations, as I've said before, on the sine and cos curves. So the only ones that are going to be more difficult than just the standard curve for sine, cos, and tan is the sine and cos. Okay, the sine and cos has the transformations. So when you have the transformations on the sine and cos curves, these are the elements, the a, b, and c, that you need to be able to fill in. Okay, so we're going to do it based on the graph and going from the graph to this, and then I think it becomes very easy to see the link then going from the function written out and to spot what the a, b, and c means. All right, so just to highlight here, so this is the note that you really want to have off by heart, I suppose, okay? Your A is your midline equation, okay? Now we'll see that, as I said, connected to the graph now very shortly. The B, whatever goes in here in front of the trig part, is the amplitude, all right? Now, the amplitude is basically the distance, all right, between your midline equation and the max and minimum point, okay? So we'll see that, as I said, now when we start to do lots of examples. So the range then is obviously going from that highest point on the graph to the lowest point on the graph, or lowest to highest is the order I have it there, which is basically going to be wherever your midline equation is, take away that value, and whatever the midline equation, add on that value. And that value is a distance, so it's always going to be a positive. We're always just looking at the distance, the length between the midline equation and the max and minimum point. And then the C is connected to the period. And this is the little equation, and this is your first equation. And this, of course, is just a manipulation of that equation. That equation you need to learn off by heart. Okay, you absolutely need to know how to figure out that C, or if you have that C, how to figure out the period. Okay, so the connection between C and the period is this. The period is equal to 2 pi divided by that value. Whatever value that is in front of the C, you'll always divide by that value. Obviously, if you're in degrees, if your graph is in degrees, you'll change that 2 pi to 360 degrees instead. Okay, and then, so that's if you want to know the period. But if you want to know the C, the best thing to do is manipulate this equation. So you have C equals 2 pi divided by the period. The period, you see, if you have the graph drawn for you, will be quite easy to spot because, and here's a little extra note for you, the period is always the shortest distance along the x-axis where the curve repeats itself. So you'll kind of see that quite clearly if the graph is drawn for you, like where is the graph repeating itself and what's that shortest distance. Okay, so we'll have a look at that again in more detail now when we start to look at examples. Okay, so the other thing I want to highlight to you before we start jumping into questions is, how do you know whether it's going to be the sine curve or the cos curve? Okay, so the thing that you're looking out from here is always from the y-axis, all right? Your sine curve shape coming from the y-axis will be this, the best way I've been describing it in the previous video is kind of this horizontal backwards S shape, okay? Starting from the y-axis, it will go up and then down like a wave like this, okay? The cos curve will do, from the y-axis, will do a U shape, okay? So that's what you're looking out for. Now, see, where your midline is not necessarily the x-axis. That depends, because if it's a transformation of the sine and cos curve, then that midline could be anywhere, okay? So it's just the general shape you're looking at, and mainly looking at from the y-axis, okay? So the other thing I just want to highlight here is if you have a minus sign function, okay? It is just going to be a flipped version of this. A minus function, and we should know this from functions, is always a reflection of the x-axis. So this would, instead of being this horizontal going up and then down, it will go down and then up. Okay, so that's the way the shape's going to come from the y-axis if there's a negative. And of course, this, instead of being a U shape, it'll flip and it'll be an n coming from the y-axis if it is a minus cos function of some sort. Is that okay? So that's useful to be mindful of, okay? If we have a straightforward sine and cos, they're the shapes we're looking at starting from the y-axis. And if it's a negative, we're looking for a flipped version of this coming from the y-axis. Okay, right, let's start some questions. Okay, so take a look at this one. Press pause if you feel confident. Try it yourself first. If not, listen carefully and I'll show you how I'm going to pull out all the information from what I see drawn in front of me. So first thing I need to identify, is it a sine or cos function? Okay, so I'm looking from the y-axis and I can see that it's going up and then down, so I know that it is sine. So that means I'm filling in these pieces of information. Okay, now this, of course, is the midline equation. Now, in this question, I can see the middle line of the shape is here at 0. So y equals 0 is that midline equation, all right? The middle of the graph, in other words, yeah. And then what comes here is the amplitude, which is always the distance between that midline equation and the max or minimum point. And I can see here that we have 1 unit, so that's 1. And here, this can be the trickiest part for some people. So this, remember, I'm going to, I want to consider what that c is. So I'm going to consider this little equation here that you need to learn off. 2 pi is equal to, sorry, c is equal to 2 pi divided by the period. Now, the period. So I know the sine graph is, of course, this shape, all right? And that's what will repeat. So that's the shape I'm looking out for. It's always this horizontal backwards S. So the shortest distance on this particular graph where that is between 0 and 2 pi. So do you see that? I can see that that's the period of this graph. That's my sine function shape. That's the shape that repeats itself. And the shortest distance on this particular graph is between 0 and 2 pi, which means it's 2 pi. So that means then that c is equal to 2 pi divided by 2 pi, which is equal to 1. So 1 goes in there. So this function is y equals 0 plus 1 times sine 1x, which of course is just y equals sine x. It's the original sine x function. Okay, let's have a look at this one. So coming from the y-axis, again, what I'm looking for here now is just the sine or cos curve. And it's coming with a U shape. That's straight what we're going into from the y-axis is a U shape. So I know it's going to be a cos function. Okay, so I want to fill in my boxes. So this one here, of course, is the midline equation. And the middle line in that graph, of course, is here at 0, the line y equals 0, the x-axis, of course. This, of course, is the amplitude. So I want the distance from that midline equation to the max or minimum points. And of course, it is 1 unit. Do we see that? That's the amplitude. So that's 1. And again, we want the c. So c is equal to 2 pi divided by the period. I know the cos curve is a U shape. So there's my U shape. That's the shape that gets repeated. And the shortest distance on the x-axis with which that is the shape that repeats is, of course, between 0 and 2 pi. So 2 pi is that distance. So I have, of course, 2 pi divided by the period is 2 pi, which is 1. So again, we've got a 1 in there. So this is y equals cos x. It's the cos x curve. Okay, next question. Again, pause if you feel confident to try this one on your own. So the first thing we're identifying, is it the sine or cos curve? So going from the y-axis, we're going straight into a U shape. Okay, so that means we're dealing with the, oops, that should be a plus. Plus something cos something x. Okay, keep the brackets around that because that's the angle. Okay, so it's not just something multiplied, it's the angle, so keep the brackets around it. Something x is the angle. Right, figuring out what each of these boxes are. The first one, of course, is the midline equation. The middle line in this graph we can see is right along here, and again is at 0, so we can sub that in. Now this time we want the amplitude. Now the amplitude is the distance between that midline equation and the highest and lowest points on the curve, so the max and the min. So there we go. This time it is a gap of, or a distance of, 2 units. So that's 2. There's a stretch of 2 on that curve. Now of course we want to have a look at what the period is to help us figure out that C value. So the period, well, the U is the shape we're dealing with a cos, and there is my U. And again, that's the shape that's repeating itself, and that period is 0 to 2 pi. It's the distance there is 0 to 2 pi. That shows that shape that repeats. So it's going to be 2 pi divided by 2 pi, which of course is 1 again. So there we go. This is y equals 2 cos x. It's the function y equals 2 cos x. Okay, let's try this one. So press pause and see how you get on with this one yourself. First thing, of course, to identify is, are we dealing with the sine curve or the cos curve? So going from the y-axis, we are going straight into a U shape. So we know it has something to do with the cos function, or it is a transformation of the cos function, should I say. Midline equation, middle line is of course at 0. Amplitude, distance between that midline equation and the highest and lowest points in the curve, is of course a distance of 1. And now, right, analyzing the period. So C is equal to 2 pi divided by the period. Now the period, so obviously it's that U shape. And there we go, that shortest distance along the x-axis. Now, it's not clear what value that is. So a really good way to analyze this is to have a little look at how many of those U shapes appear in your original period. 2 pi is always the original period. Okay, so I might just do a different color there just so that you can see where I'm getting those 3 shapes, 3 U shapes, 1, 2, 3. Well, if there are 3 of those shapes appearing in the original period, all right, then I know that there's a squash on the curve, and there's triple the amount of curve in the original period, which means that's going to be 3. So if it's not clear on your graph, and that might often be the case, exactly what that value is along the x-axis, okay, then if you just analyze how many of the U shapes are in the original period, you'll know what the squash is. And so what that value must be is it must have been the 2 pi divided into 3. In other words, 2 pi divided by 3. And 2 pi divide by 2 pi, divide by 3 is, of course, where the 3 comes from. But it is easier in this scenario to just analyze how many of the shape is between the original period, 0 and 2 pi, and that will give you that number. Okay. Okay, next question. Pause the video if you feel confident here. Again, we're going to go from the y-axis, and we're analyzing the shape. So it is going up and then down. This is the shape coming from the y-axis, which means that we are dealing with a transformation of the sine curve. Okay, so the midline equation is, of course, 0. The amplitude, the distance between that midline equation and the max and min is, of course, 1. And now my c value. So I'm going to analyze my original period is 2 pi. Okay, how many of my shape, and of course that's my original shape, there we go, how many of them is in that original period 2 pi? And of course I have 2. So 2 is what's going to go in there. Do you see how easy it is to jump to that? How many of that horizontal backwards S shape is there in the original period? That tells you what the squash is on the curve. There's twice as much of the curve in the original period, so that is 2. Okay, and if I was given this, right, so let's say I'm given the y equals sine 2x, which is what this function is. I don't have the graph in front of me, and from this I have to figure out the period. Well, then you would use your original equation. The period is equal to 2 pi divided by c. So 2 pi divide by that c, which is there, 2, which is pi, which means pi, you see, is the period. And I can see that clearly here, that that's the shortest distance where that graph, that piece, that shape starts to repeat itself. Okay, so can we see that link? There's a couple of different ways of looking at it, depending on the question, will be depending on which is the easiest one to use at the time. Okay, next question. So pause the video and see how you get on with this. Okay, so we're looking from the y-axis and we're going up and then down. So it has got to be a transformation of the sine function. Now, this, of course, is the midline equation. So again, we're at 0. This, of course, is the amplitude. So here now, the distance from the midline equation to the max or min point. What is that distance? Of course, here it is 2 units. So 2 goes in there. And now what my number is. Okay, so there's 2 pi, my original. So how much of that sine horizontal S shape do I have? There's 1. There's 2. And there's 3. So I have 3. So this function is y is equal to 2 sine 3x. And if I want to know what that period was, I would just do the equation 2 pi divided by c. The period, therefore, is 2 pi divided by 3. 2 pi over 3 is the period of that graph. Okay, next question. All right, take a look at this and pause the video and see how you get on. Okay, so going from the y-axis, I can see we're jumping straight into a U shape. So I know it's a transformation of the cos function. And now let's fill in my boxes. So this is a midline equation, 0. This is the amplitude, so the distance between that midline equation and the max or min. So in this case, we have a gap of 3. So 3 is the stretch. And now let's have a look at the period. So there's my original 2 pi. How many of the cos U shapes do I have? So there is 1. And there is 2. So I have 2. All right. So in other words, the period is equal to, of course, 2 pi divided by c. And that c, of course, is 2, which is pi. And I can see that here. There we go. There's the shortest distance, that u. I can see that clearly here as well. Pi is that shortest distance. So that is the period. Okay, next question. Press pause and see how you get on. So looking from the y-axis, I can see straight away we're going into a U shape, which means it is transformation of the cos curve. Okay, let's fill in our boxes. Now, the midline equation. Okay, so it's not this time, okay? That's not the middle line of this curve. So let's go up one. What about that there? Yes, if I was to draw a line there, and I'm going to do that, that is cutting that graph in half. So that's your middle line, yeah? And your equation is y equals 1. So 1 goes in there. Okay, amplitude is the distance from that midline equation to the max and min point. So that now is a gap of 2. All right, so the stretch is 2 on the curve, just everything's shifted upwards. And now the period. Okay, so there's my original 2 pi. It's the cos curve, so we're looking for the u. How many times does that u appear, that shape appear in the original period? It is, of course, just 1. So there we go. Y is equal to 1 plus 2 cos x is the function of this graph. Okay, next question. Press pause, see how you get on with this. So from the y-axis, I'm going up and then down. Okay, that of course is a sine wave. So it's got to be a transformation of the sine curve. So let's fill in our boxes. First one's the midline equation. So the midline equation, obviously it's not this one down here, or along here, we'd have to go up another one. There we go. That would be the middle line. And of course, that line there is y equals 2. So 2 goes there. Now, amplitude is, of course, the distance between that midline equation and your max and minimum points. So we're talking about a gap of 3. And now we'll analyze the period and how many times we've got maybe a squash in the original period. So have a look at our shape. Our original shape, of course, is this. How many of those appear in my original period of 360 degrees or 2 pi? And I have, of course, 2 of them. So there we go. So the period is actually pi. The c value is 2. So y equals 2 plus 3 sine 2x is that function. Okay, next question. Press pause, see how you get on. So analyzing from the y-axis, we're going straight into a U shape. So I know it is a transformation of the cos curve. And then we're looking at midline equation. Okay, so the middle line has got to be down here this time, which of course, is here at -1. So -1 is going in there. Okay. Now, what do I need now? Okay, the amplitude. So the distance between that midline equation and the max and min, okay, we just have a gap of 1. And now looking for our c, well, there's 2 pi, our original period. It's a cos U shape I'm looking at. How many of them have I got? I've got 1, 2, and 3. Right, I have 3 of them. So I have a triple squash, if you like. So there we go. So we have the function y equals -1 plus cos 3x. Okay, next question. Press pause. See how you get on with this one. All right, coming from the y-axis. Now, that's not quite a U shape, because you see the way this goes up as far as here. If that was a U shape, I should start up at the same height as I then turn and go back up to, if that makes sense. So we actually have, what's the shape repeating here? This is the shape I have. Now, if you remember back to what I highlighted at the very start, there's two things you want to watch out for. You've got either the horizontal backwards S or the U. Now, this is what I mean. See how high that is? That goes right back up to that height again for that U. Do you see that? I don't have that. What I have is something going down and then up, which is actually a reflection of that shape. It's not a U shape, it's a reflection of the sine wave, okay? So what I have here is a negative sine function, okay? So it is a sine function, but it's a minus because it's a reflection of that original shape, okay? So that's what I have here. All right, so that's harder to spot, but watch out for it. If it was a U, it would have to start up there and then go back up there. That's not doing that. It is going down and then up, a turn and a turn, which means it's a reflection of your original sine wave shape. All right, so now I've dealt with that. Okay, now midline equation. This time, my middle line is there at 1. Okay, the amplitude is 1. And now that shape, so the shape I'm looking for this time is one that goes down and then up. All right, there is only one of them in that original period 2 pi, so that is 1. So this is the function y equals 1 minus sine x. Okay, try this question, press pause, see how you get on. So going from the y-axis this time, I have quite clearly an N shape. All right, so that is a flipped U shape, which means it has got to do with the cos function. And since it's a flip, it's going to be minus. Okay, so put that minus in. Okay, that one's kind of easier to spot than the last one because it's an N instead of a U. So it's quite obviously the reflection of the original cos function shape. So that midline equation is there at y equals 2. Amplitude is of course 1. And let's have a look. So there's 2 pi, my original. So I'm looking for N shapes this time. And how many of them do I have in that original period? I have 1, and then I have another one, 2. So I have 2 of them. So I have y equals 2 minus cos 2x. Okay. Okay, second last question. Press pause, try this one yourself. So looking from the y-axis, we are going up and then down. That is quite clearly a sine function. All right, and it's not flipped or anything. Okay, now midline equations. So middle line I can see is here. There we go, at 2. So there we go, amplitude. All right, so what's that distance? We have, of course, 3. The distance between the midline, the max and min. And then, of course, we want to analyze the period, and that horizontal backwards S shape, there's only one of them in that, the original period 2 pi. So that means that it's just that C value is 1. So this is y equals 2 plus 3 sine x, that function there. Okay, last question. Okay, pause the video, see how you go with this one. Okay, so going from the y-axis, I can see this curve is going up and then down. Now we've kind of gone off here. We haven't quite finished what looks like it's starting like the sine wave, doesn't it? I can see it's going from the y-axis. We're definitely going up and then down, and it would obviously continue along like that. So I know it has to have something to do with the sine curve. All right. Now, all right, let's have a look. Although I've only got some of the graph here, okay, I do know how it's going to continue on, okay? So I can imagine what's going to happen here. So I can, and I do have enough to analyze this. The midline equation, well, I can see already that, look at that line there, you've got the same amount of space either side of that line there. Look, from your highest to your lowest point, because it's going to continue like that and back up and so on. So the midline equation is here at 0. The amplitude, now I can see that here. I do have enough information, look, there and there. So it is a gap of 3. Now the period, now 2 pi, there's my original period. And normally I'm analyzing how many of my horizontal backward S shapes I have within that period. But I can see here that I don't even have one full one. So how much of the original shape do I actually have in that original period? I only have half of it, don't I? So that is actually a half. I only have half that original horizontal backwards S shape, only the top bit, you see, it would then go on with the bottom bit. So there's only half that original shape in that original period, which means then that has to be a half. So my function is y equals 3 sine a half x. And if I had to analyze what that period was then, okay, remember our equation? The period is equal to 2 pi divided by c, and that c value is half. And 2 pi divided by half, now be careful here, 2 divide by a half, how many halves are in 2 in other words, is 4 pi. And that would make sense because it would continue on until that spacing doubled. So 4 pi is the actual period of that graph, and a half is the value for the c.